And finally, solving logarithmic equations. So the way this goes is there's four main types. The first one, you don't really even need logarithms at all, but you could use them. Um, this will be on the test, so it fits in today's lesson more than the others. So I'm going to put type 1. Not that you got to memorize what I'm calling the types. I'm going to put don't really need logs here. All right, so this is kind of an exercise in logic. Let's say I have 5 to the third. Let's make it 5 to the x equals 25 to the 2x minus 1. So, you know, this is a different kind of problem. We want to solve for x, but the x is in the exponent. That is a problem. So what we're going to use in this case is we're going to use logic. This type 1 problem, notice that 25 is 5 squared. Basically, we're going to play an exponent game here. I'm not going to even touch these powers. I'm going to leave this as 5. And what I want to do is rewrite 25 as 5 squared. Now, there's a property of exponents that says if you have a power to a power, you multiply, and that would be distributed. So this is going to turn into 5x equals 5 to the 4x minus 2. 4x minus 2. Now, the whole reason we do this is because we've got to get these bases to match. If I have 5 to a power equals 5 to a power, then it must be true that this power is the same as this power. These have to match. I can't do it when these are different numbers. I can't just say x equals 2x minus 1. These have to match perfectly, and then I can do that trick. And now I'm going to solve this. I could take away 4x from both sides. And then I'll divide by minus 3. And I get x equals 2/3. So that would be the answer to my problem. So, you know, this could be like 7 to the x equals 49 to the 2x, right? So if you have to be able to rewrite this number as that number to a power. That's the whole trick. If you can't do that, you can't use this method. That's a different type of problem. Let's try type 2. Type 2 looks like this. A number to x stuff power equals another number. So if you see that, let me give you a for instance. 5, let's just make it to the x equals 31. Now, 5 squared is 25, and 5 to the third is 125. This is not a whole number answer. How do I get what x is? That is a problem. What we got to do is go back to lesson 1 and rewrite this as a logarithm. Watch what happens. Log base 5 of 31 equals x. See, yeah, I got to brush off those skills. It's very important to be able to rewrite exponents as log, because look at this. I can plug this into my calculator. Either I can plug it in directly, you know, if you have the nice calculator, but even if not, I can just type in x equals log 31 over log 5, and when I do that, I get 2.134. And that would be my answer there. All right, let's try another one where it's a little more going on. Let's say I have 11 to the 3x minus 5 equals 1027. Well, I can't rewrite this like my last type problem, you know, like make this like 5 squared or something. So what I have to do is rewrite this as a logarithm. So this is going to be log base 11 of 1027 is equal to that power. This I punch into my calculator. Log 1027 equals, divided by log 11 equals, and now I'm getting 2.89 equals 3x minus 5. And now I'll add 5. And I'll divide by 3. And my final answer is x equals 2.63. Okay, so that would be type 2. You've got to rewrite as a logarithm, and then you can solve it. Okay. Now, type 3 is when you have a logarithm on one side only. There's a logarithm only on one side of the equation. So, for example, log base 7 of 3x plus 1 is equal to 4. How the heck am I supposed to figure out what x is? That I can't plug that into my calculator. It's got a variable. So here I want to rewrite it as an exponent. Rewriting is a big part of logarithms. How do I rewrite this as an exponent? That base to that power equals 3x plus 1. See how if I can rewrite it, it unlocks the problem? If I can't rewrite it or I don't know to rewrite it, I'm going to spin my wheels. I'm not going to be able to answer this question. But if I do this, I could just 7 to the 4th. Been doing that in our calculator a long time. And now I'll subtract 1. And it looks like in this case, x is equal to 800 after I divide by 3. Let's try that one more time. Let's switch up. Let's do it like this again. Let's do log base 5 of x squared minus 1 equals 200 even. Okay? Give you a little pause so you can get started here. Rewrite it as an exponent. 5. Oh, I wonder if 200. Yeah, that's too big of a number. My calculator said overflow, so I couldn't give you that up. It's too big. 5 to the 200 is too big. Let's make it 3.75. Sorry about that. So I got to rewrite it. 5 to the 3.75 equals that stuff. Calculator didn't like it because 5 to the 200 is an awfully big number. But this is much better. Equals x squared minus 1. So I'm going to add 1 to both sides. And then I'm going to take the square root. And I'm going to get x equals plus or minus 20.44. Don't forget the plus or the minus there. Okay, one more to go. All right, so, well, back in type 3, I'm going to go back to fix your notes. For type 3, I should word it this way. At least one term is not a log. Let's see what I mean by that. Why am I thinking I need to add or change this? Because I just thought of the way I had it, like number 4, I had logs on both sides. It's a little oversimplified. Watch this. Log base 3 of x plus log base 3 of 7. No, let's make it this way. Equals 10 minus log base 3 of 7. See, now, if all you were doing was looking to see, oh, there's logs on both sides, so that's not type 3. Actually, this is type 3. See how there is logs on both sides, but I could move this log over to this side. And then I could merge those with rule 1. And now it's type 3. See, you might have to tweak it a little bit. So what makes it type 3 is this. At least one term, see this one right here, has to be a non-log term. So that that means you can get it by itself on one side. Let's just finish this off. So 3 to the 10th is 7x. So 59049 is 7x, and if I divide by 7, I get x equals 8435.57. So, sorry about that. Yeah, type 3 is better stated. At least one term is not a log. That is how you tell. So let's go back to type 4. All terms are logs. Everything on both sides must be a logarithm, and then it is a type 4 problem. All right, so let's start simple. So let's say I have this. Now, you're going to like what you see here, but the problem is people oversimplify. So watch what I'm doing, but then pay close attention in the next example. If you have one logarithm equal to one logarithm with no numbers in front of the logs, then you may do this. I'm not dividing. This is just like a next step. I can literally just drop the logarithms out of the problem. I'm not dividing by log. It's just an exercise in logic. Since we're not in class, this is the rule. If you have one logarithm equal to one logarithm with no numbers in front, then you may drop the logarithms out of the problem and finish it up. So I would take away 1 from both sides and get 2. See, that's very simple. However, people go crazy with that. Remember what I just said. It must be 1 log equal to 1 log. So let me give you the next problem. So here, right, I have 3 terms. Logs, they're all logs. And what do you think people want to do here? They go x plus 5 equals 12, so x equals 7. And that is wrong. I can't give you any partial credit for that because you're oversimplifying. Listen again to what I said. If you have a single log equal to a single log, then you may drop the logarithms. Well, that's not true here. But we can fix that. If I bring these together with rule 1, then I have a single log equal to a single log, and then I can drop the logarithms out of the problem. And then my answer would be 12/5. See, when I give this test, everybody just goes x plus 5 equals 12. They oversimplify it. You've got to get it to be 1 log equals 1 log, or you cannot use this process. All right, let's do another one of these. Now let's make this one a little more obnoxious. All right, let me think just a second here. I cannot just write x plus 1 plus x minus 2 equals 6. I cannot do that. I've got to merge these together. Well, how do you merge those together? The first rule says you can do that, but you have to multiply these together, and that's a FOIL problem. That's x times x minus 2x plus 1x is minus x minus 2. And now that I merge them, now I can drop the logarithms out of the problem. So I'm going to go over here. And what is that? That is a quadratic. This goes back to our previous unit we covered. How do I solve this? Well, first I got to get everything equal to 0, so I'm going to subtract 6. I try to FOIL that and I can't, so I'm going to have to use the quadratic formula. Yep, that never goes away. So I'm going to get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so up here I'm seeing 1 minus times plus times minus is plus 32. So I'm looking at the square root of 33 here. So the square root of 33 is 5.74. So I'm going to get two answers. 1 plus that divided by 2. And 1 minus that divided by 2. Now, technically, we'd have to throw this answer out if we were in class and we had more time to discuss this. You know, I'd be more picky on that. But on this test, I will be satisfied if you leave that negative. But technically, I'll just tell you, but you're not responsible for it. You cannot have the logarithm of a negative number if it's a positive base. So if I had a minus 2.37, this would be log of minus 1.37, and that won't work. If you plug it in your calculator, log of negative 1.37. See how it errors on me? And so technically this answer would have to be thrown out. But at this stage of the game, I'd be very content with the fact that you knew how to handle the logarithms, you remembered how to do the quadratic formula, and you got your two answers. It is very important you practice these problems. Send me your questions through email. This is the last unit, so be sure you go through the review. You're doing your practice problems in the homework, and the next thing up is the test. All right, take care of yourselves. I'll talk to you later.